Hello community! After I published here the latest paper on Monday yesterday, there was a publication by Hugging Face and they gave us a unified tool use algorithm where they support now chat templates with tool support. And they are all now available from Llama to Cohere models. So this is beautiful because now we have developers, we can define tools in a model agnostic way. We have an automatic conversion from whatever you have to a JSON schema, and we have a standardized tool call and response handling integrated for different LLMs. So the tool building and the tool use process is now simplified, and in my post I've given here all the information how to have an intro collab here, the complete code for the documentation, and a complete tool use code example if you want to go there. And of course, in my latest video where I show you how to code multi-agent reinforcement learning, I give you 20 different code examples, plus I show you the latest ReDAL and agent scope implementation, how to build multi-agent code. You can immediately apply this new multi-tool interface here for your multi-agent reinforcement learning. But now, let's dive into our AI research publication here on this beautiful Tuesday with the first one. LLM model-based agent framework for electric vehicle charging behavior simulation from our colleagues in Shanghai, China. They have an interesting idea. They have now here the framework comprises several models: the persona, the planning, the perception, the memory, the decision making, the reflection, the action, and the environment to build here sophisticated adaptive simulation. And the framework's ability to generate personalized user profiles and real-time decision for advancement for urban electric vehicle charging management. Interesting idea to have this here to optimize here your electric vehicle charging behavior. Next one, can an oracle prevent harm from an agent? So we are here into the design here, probabilistic safety guarantees. What I really like here is the title, Can We Safe by Design AI? Can we build an AI that is safe by design? And they have here a deep look here, University of Montreal, University of California, Berkeley, Imperial College London. They have here a detailed analysis of this topic. Multi-agent planning using visual language model. Rome, Italy, beautiful. Hello there. You see immediately what it is, multi-agent planning. So we have here robotic input task, wash the knife and put the bread in the fridge. You see here the visual interpretation here of the different sensors of the robot. And then you have here your multi-agent system that identifies here what to do. Have here the objects identified. The LLM tells it what to do. The vision language model understands exactly where is which object. Then we have here the planning. You have a planning agent doing all this work. And this sounds like an absolute fascinating work that I have to read today. In context exploiter for extensive form games sounds a little bit strange at the first moment, but if you look closely, this is really interesting. Because we know in game theory we have the Nash equilibrium, a widely adopted solution concept due to its stability property. However, we pose here a new game solution question: can we learn a model that can exploit any, even a Nash equilibrium opponent, to maximize their own utility? And they introduce a novel method, this in-context exploiter, to train a single model that can act as any player in the game and adaptively exploit opponents entirely by in-context learning, ICL. Sounds absolutely fascinating. You have to read this. Next one, low-dimensional federated knowledge graph embedding via knowledge distillation, here from Singapore. Let's have a look at this. So here we have federated knowledge graph embedding aims to facilitate collaborative learning of entity and relation embeddings from distributed knowledge graphs across multiple clients while preserving data privacy. This is an absolute interesting paper. Next one. Let's have a look at neuro-symbolic methods for rule mining. As you can see here, we address the problem of rule mining beginning with essential background information. Yes. where we are. The schema of knowledge graphs can be represented using ontological axioms and/or rules. Rules can be used for explainable inference for tasks such as link prediction or fact-checking. Formulating these rules manually is demanding, and that for that reason, automatic rule learning approaches have attracted attention, and this is the content of this paper. Sounds absolutely fascinating. If you are into neurosymbolic methods for rule mining, this is your paper. Next one, what we have, scaling virtual worlds with Delta Engine. Okay, let's have a look here. We focus on virtual world, a cyberspace where people can live in an ideal virtual world, shares a great similarity with our real world, evolving nature reflected by the individual's capacity to grow and thereby influence the objective worlds. Such dynamics are unpredictable and beyond the reach of existing systems. Therefore, the authors propose a special engine called a Delta Engine to drive this virtual world. Delta associates the world evolution to the engine expansion. Okay, consists of a base engine and a neural proxy. Okay, I understand, but we have here the GitHub code. So if you are into this, why not have a look at this paper? Cognitive revolution in interpretability, from explaining behavior to interpreting representations and algorithms. University of Illinois, interesting what we are looking at here. Mechanistic interpretability has emerged as a distinct research area studying the features and implicit algorithms learned by foundation models such as LLMs. We aim to ground here the mechanistic interpretability in the context of cognitive science, which has long struggled with analogous question in studying and explaining the behavior of black box intelligent system like the human brain. Okay, I see where this is going. Department of Mathematics, that looks interesting. Let's have a look. Root cause attribution of delivery risks via causal discovery with reinforcement learning. Okay, Boston University. A novel approach to root cause attribution of delivery risk within supply chains by integrating causal discovery with reinforcement learning. As supply chains become increasingly complex, traditional methods of root cause analysis struggle to capture the intricate interrelationships between various factors, often leading to spurious correlations and suboptimal decision-making. Our approach addresses these challenges by leveraging causal discovery to identify the true causal relationship between operational variables and reinforcement learning to iteratively refine the causal graph. Okay, we understand where we are. Interesting application to the supply chain. Next one, urban region pre-training and prompting. Wow, what is this? A graph-based approach, okay. Chinese University of Hong Kong, Southeastern University, okay. Okay, let's have a look at this. So we have here a region A and a region B. Region A and Region B showcase typical urban environments. In this example, spatial structures are demonstrated by the proximity of residences to parks and shops, which enhance community convenience and accessibility. Functional layouts are characterized by the clustering of similar entities within the areas, such as shops in commercial areas and schools in teaching areas. Okay. Despite the broad similarities, each urban region and downstream task possesses unique details. Can we design urban region representation framework that effectively integrates generalizable knowledge while accommodating the specific needs of distinct tasks? Urban planning now transformed to a virtual space of an urban region representation, learning, and an urban computing project. Fascinating. Future looks absolutely fascinating. Exploring and learning structure. Give me a second. No, wrong one. Active inference approach in navigational agents. Okay. Ghent University. Inspiration from animal navigation strategies. We introduce a novel computational model for navigation and mapping rooted in biologically inspired principles. Building this insight, we integrate traditional cognitive mapping approaches with an active inference framework to learn an environment structure in a few steps, through the incorporation of topological mapping for long-term memory and active inference framework for navigation planning and structure learning. Our model can dynamically apprehend environmental structure and expand its internal maps with predicted beliefs during exploration. Interesting. No idea what it is about, but maybe this is an interesting read for you. This is something you have to read, the AI Scientist. Yes, fully automated, open-ended scientific discovery. Hey, finally we have an AI system that substitutes here the scientists of this world. We have here equal contribution by University of Oxford, University of British Columbia. Okay, one of the grand challenges of AI is developing agents capable of inducting scientific research and discovering new knowledge. Yes, yes, yes. This paper presents here the first comprehensive framework for fully automatic scientific discovery. Enable frontier large language model to perform research independently. And they're so nice, they communicate their findings. We introduce the AI Scientist, which generates novel research ideas, writes codes, executes the experiments, visualizes results, and describes its finding by writing a full scientific paper, and then runs a simulated review process for evaluation. Unbelievable, and we have the code for this. Now we're gonna make some brand new scientific discoveries. Okay, next one. Tailoring knowledge graph embedding for ontology alignment. This sounds interesting. University of London, University of Oslo, University of Manchester, UK and Norway cooperate here. Ontology alignment. Oh, I see. Achieving semantic interoperability as the number of available ontologies covering intersecting domains is increasing. Okay, we present the theoretical foundation, implementation detail, and experimental evaluation of our proposed extension that covers now here. Where is it? An ontology alignment. So, in my words, it finds here similar information pieces in knowledge graph embedding to, let me put it in a simple way, to reduce here maybe a complexity question. Okay, next one. Can we rely on LLM agents to draft long horizon plans? Travel plan as an example. So how far in the future can our LLM agents really be valuable for us as consumers? So we have here LG Electronics, Toronto, Canada. Absolutely fascinating. LLMs have brought autonomous agents closer to artificial general intelligence. Hello, baby. Due to their promising generalization and emerging capabilities, there's a lack of studies on how LLM-based agents behave, particularly in demanding real-world planning tasks. In this paper, as an effort to fill this gap, we present our study using a realistic benchmark. We have a travel planner. This is a new agent. Are LLM agents robust enough to lengthy and noisy context when it comes to reasoning and planning? Can few-shot prompting adversarially impact the performance of LLM agents in scenarios with long context? Okay, so we understand here. They propose here a feedback-aware fine-tuning, which leverages both the positive and the negative feedback, resulting in substantial gains over supervised fine-tuning. Hey, we have a new training methodology. Interesting. Next one. Visual Agent Bench. Okay, let's have a look at this. Towards LLM models as visual foundation agents. Wow, now we're really mixing our wording, visual foundation agents. Tsinghua University, Ohio State, Peking University, LLMs. Okay, so we have here a look at this, and I do not understand anything. So we have to read it. We have some code. This is very nice. LLMs have ushered in a new era in artificial intelligence, merging capabilities in both language and vision to form highly capable visual foundation agents. These agents are postulated to excel across a myriad of tasks, potentially approaching, yes, of course, we introduce Visual Agent Benchmark, a new benchmark, a comprehensive and pioneering benchmark designed to train and evaluate LLMs as visual foundation agents across diverse scenarios, including embodied graph user interface and visual design. Okay, a new benchmark, beautiful. Next one. Let's go with LLMs for cross-language code clone detection. Code clone detection. Okay, University of Luxembourg. Hello, Luxembourg. Great that you participate. Copy-pasting a code fragment with or without change is common practice in software development, and this action produces code clones. Now we know what they mean. It reduces the quality of the code, making maintenance costly and can be the source of bugs. Research shows we can find about 5 to 23% of clones in a software system. We distinguish 4 types of clones. Okay, and they go on and they have now this code clone detection system. Okay, beautiful. Yes, of course, LLMs, you can train this for this particular pattern. Next one. Hey, that sounds interesting. The role and application of airport digital twin in cyber attack protection. Okay, let's have a look at this. Airports, the threat facing airports from growing and increasing sophisticated cyber attacks has become evidence. Like any public infrastructure, you can say, airports are considered a strategic national asset, so protecting them from cyber attacks, yes. And they use this by using a digital twin. The integration of digital twins with generative AI algorithms can lead to synergy and new frontiers in fighting cyber attacks. This paper exemplifies ways to model cyber attack scenarios using simulation and generate synthetic data for testing defense mechanisms. Okay, we understand where we are and where this is, the application this is heading for. Next one. Advanced oncology with federated learning. This is interesting. This is about transcending the boundaries in breast, lung, and prostate cancer. And we have here Maastricht University, University of London, University of Oxford, Hamburg, Germany, Mathematical Academy of Athens, Helmholtz-Zentrum Dresden, and Pfizer in New York. Hello, Pfizer. So, federated learning has emerged as a promising solution to address the limitations of centralized machine learning in oncology, overcoming privacy concerns. Yes. Okay, oncology. Well, it's the real-world implementation and impact of federated learning on cancer care, demonstrating its effectiveness in enhancing machine learning generalizability, performance, and data privacy in clinical settings. Okay, so this is about how can we have our local privacy respected of our personal medical data, but have a federated learning in multiple nodes in our network. This is absolutely fascinating. I will have a look at this 100%. Next one. So, SemiSupervised one-shot imitation learning. Okay, University of California, Berkeley. This sounds interesting in cooperation with Google DeepMind. This is always a good combination to learn something new about here. Machine learning one-shot imitation learning aims to imbue AI agents with the ability to learn a new task from a single demonstration. I see where they're going. To supervise the learning typically requires a prohibitive large number of paired expert demonstration. Yes, of course. This means trajectory corresponding to different variations of the same semantic task. Yes. To overcome this limitation, they introduce a semi-supervised problem setting where the learning agent is presented with a large set of trajectory with no task labels. This means an unpaired dataset. This is not so nice. Along with a small dataset of multiple demonstration per semantic tasks. A paired dataset. I see. So if we do not have enough high-quality training data, this means a paired dataset for this particular semantic task, and we have other unpaired data sets, so no task labels to our trajectories, they now kind of find a way to utilize the system. Featured learning requires an agent to effectively leverage weak superposition from a large data set of trajectories. Okay, I see what they do. Oh yeah, here we have it. So the supervised setting, we have here the paired demonstration, okay, and then we have a lot of unpaired demonstration, okay, and a small paired of high quality data. I see what I mean here. So they go with the encoders then used to construct a pseudo-paired trajectory set by retrieving the k nearest neighbor for each trajectory. We can then train the students on this pseudo-label dataset. Okay, I see what they do. Similarity, closeness. Nice, definitely have to have a detailed look at this. UC Berkeley, always an interesting read. And the next one, here we go. The impact of internal variability on benchmark deep learning climate emulators. Wow, this sounds interesting. Massachusetts Institute of Technology, Department of Earth, Atmospheric and Planetary Sciences, Scripps Institute of Oceanographic, MIT. Nice. Okay, finally AI applied for climate change. Linear regression-based climate emulators outperform deep learning on 3 or 4 spatial atmospheric variables in the benchmark, the climate bench. Yes, I definitely have to read this. This sounds absolutely fascinating. Okay, the next one is from text to insight, leverage LLM models for performance evaluation in management. Yeah, I've chosen this paper because I think this is a very new application area that we go now here for management task in our companies, and we see how our LLMs now perform if they move up the ladder here to the management suite. Tsinghua University, okay. Enhance objectivity in organizational task performance evaluation. Various task performance output that LLMs can serve as a reliable and even superior alternative to human raters in evaluating knowledge-based performance outputs, which are a key contribution of knowledge workers. Hey, now GPT-4 is evaluating the work of human knowledge workers. This is interesting. Hello, China. I have a feeling why you do this. Okay, they go on. We also find that LLMs are prone to contextual biases, such as the halo effect, mirroring human evaluation biases. Are capable of extracting meaningful constructs from text-based data. Their scope is currently limited to specific forms of performance evaluation. So machines are still not perfect. Okay, there's still hope for society. Next one, here we go. Logically constrained robotic transformers for enhanced perception action planning. My goodness. Okay, this is of course from Carnegie Mellon University. What other university is working on this particular thing? I get an idea. Okay, so LLM, large foundation model-based planning. There's a dire need to ensure that the output aligns with the stakeholders' intent. When these models are deployed in the real world, the need for alignment is magnified due to potential costs of life and infrastructure due to unexpected failures. Temporal logic specification have long provided a way to constrain system behavior, a natural fit for these use cases. However, in this work, we propose a novel approach to factor in signal temporal logic specification while using the autoregressive transformer models for trajectory planning. Wow! So we see here our BERT, our clip encoder, MLP, state action encoder, causal transformer block with cross attention, everything that we know. So this sounds to be a real interesting paper that we all have to read. I hope you do agree with me here. Trusting your AI agent emotionally and cognitively. I have chosen this particular study to show you here because it's a little bit older, as you can see, but this is interesting because if we choose an LLM or any AI system, we choose as human, and we have, as a human, emotions, we have some cognitive bias, and they explore here what is it that we as human, we kind of like one AI system or another system. Now, this is now completely different. This is now about continuous image speech decoding using high density of neurons and prompt tuning for advanced human AI interaction. This is here, United Kingdom, the Mind Portal, Carnegie Mellon University, of course, what else? And if you look at this, we are here in the area, where is it? Of brain to text AI, we are here in the brain interface area. Hello, Elon. I think there could be some competition coming your way. Okay, let's go on. Then we have, this is something nice. This is not so much yet with an AI application, but this is just interesting here, a cost-effective eye tracker for early detection of mild cognitive impairment. So, you know, there's now this new research that shows us if we have here the analysis of the eye movements here, an eye tracker, this is maybe a sign that we have an idea of a detection of some upcoming mild cognitive impairment. Alzheimer's disease, you know what this means. And they have here a low-cost eye tracker. Currently, in my understanding here, they are missing out here, the researcher from Italy, on the AI evaluation database here. So maybe we can optimize here this beautiful idea with some AI evaluation software. Oh yeah, this is nice. Mathematical models of computation in superposition. So if you're into radical physics or quantum physics, this is for you. Finally, we have here a mathematical model, and this is done by Caltech, of course. Caltech, Berkeley. Real nice. Okay, if you know this, you know this, you know this is the paper for you. Next one. Investigating instruction tuning LLMs on graphs. Okay, again, our old topic here, what we do with graphs. Recent advancement in LLMs, in LLP tasks. There's a growing interest in applying LLMs to graph-related tasks. This study delves into the capabilities of instruction following LLMs for engaging with real-world graphs, aiming to offer empirical insight into how LLM can effectively interact with graphs and generalize across multiple graph tasks. Interesting. Yes, this is it. So we have here graph representation, a graph sample here. Then we have the graph representation either in JSON or in a natural language. And then we have the graph, the task generalization of this graph. So you understand immediately what this is all about. Next paper. Oh yeah, this is an interesting paper I've chosen to show you. This is Mitigating Metropolitan Carbon Emission with Dynamic Eco-Driving at Scale. This is done by MIT and ETH Zurich, plus the Utah Department of Transportation. Hello, Utah. And this is real nice because if we have a lot of autonomous vehicles and we have deep reinforcement learning, and we want to reduce here our carbon emission, and we have some eco-driving, how can AI system minimize now, slightly influencing here your driving of your autonomous vehicle? How can we have a contribution to reduce here the emissions of transport? And they say here, diversity of the transportation make it formidable sector to decarbonize. We consider an emerging opportunity to reduce carbon emissions, the growing adoption of semi-autonomous vehicles, which can be programmed to mitigate stop-and-go traffic through intelligent speed commands and therefore reduce emissions if you do not have an EV. But would such economic or dynamic eco-driving move the needle on climate change? And they found out in this study, vehicle trajectories optimized for emission can cut citywide intersection carbon emissions by 11 to 22%. And this is amazing. And they also find that 10% eco-driving adoption yields 50% of the total reduction, and nearly 70% of the benefits come from 20% of the intersection. So this is nice. They give us the code. So if you are into Department of Transportation planning task, how you optimize the traffic flow in your city. I think this is a study by MIT you definitely should have a look for. And this is why I've chosen it to show you here in our selection on Tuesday. Now let's go back to biomedical, to medical task. We have here universal retinal foundation models via knowledge-guided masked modeling. We are here in Singapore, National University of Singapore, eye health, and they have here now a very specific model here, a retinal foundation model, and they aim to learn generalizable representation from diverse retinal images, facilitating label-efficient model adaptation across various tasks. They have a lot of medical sensors, and if you want to bring all together and have one, if you want, retinal foundation model here, this would be great. So a medical application here of our AI system. And then we have quantum secure. No, this does not belong here. This belongs to my other channel. Sorry. Yeah, this is about something, yeah, multiple deep learning. If you want, this is a MIT. And it is all about, where is it? New linear algebra engine, but what they try here, modern secure computation schemes are built to homomorphic encryption, which allows universal computation of encrypted data and preserves the security of both the input and the output of the computation. The recent development of that is state-of-the-art homomorphic encryption scheme for secure machine learning, but real-world applications are limited due to their massive computational overhead. And they introduce here a new linear algebra engine for information theoretical secure computation. Real nice, but you have to be a little bit into quantum physics, otherwise this would be a hard read for you. Okay, talking about a hard read, attention in a low rank space for key value cache compression. This is by Purdue University, beautiful. So, a long context length and large batch sizes, the key value cache which stores the attention keys and the values. This emerges here as the new bottleneck in the memory usage during inference. And to address this, they propose here a new eigenattention, which performs the attention operation in a low-rank space, thereby reducing the key value cache memory overhead. Currently is orthogonal to existing key value cache compression techniques. And this is new. This has a beautiful GitHub library for you to experience. So if you are into cache compression, why not give this study a detailed look? Oh, there I am. Okay, next one. Reference-free hallucination detection for vision language model. Okay, Mohammed Ben Said, University of Artificial Intelligence, and the Technical University of München. And they have here to detect hallucination in vision language model. Explains a little bit if you're into this work. Plus, next one is motion planning using topological refinements. This is interesting, from Italy. This is a task and motion planning. This is a problem of finding a solution to an automated planning problem that includes discrete action executable by low-level continuous motion. In our robotic system, we propose a general and open source framework for modeling and benchmarking here our task and motion planning problems. And they introduce an innovative meta technique to solve those problems involving moving agents and multiple task state-dependent obstacles. Okay, robotic, nice application. Have a look at this. This is funny, you know. A single goal is all you need. We know this title in a slightly modification. Skills and exploration emerges from contrastive reinforcement learning without rewards, demonstration, or sub-goals. This is interesting. This is some deep stuff. Princeton University, beautiful. In this paper, we present empirical evidence of skills and directed exploration emerging from a simple reinforcement learning algorithm long before any successful trials are observed. Skills emerge before the agent has ever successfully placed the block at a global location and without the aid of any reward function demonstration or manually specified distance metrics. Once the agent has learned to reach the goal state, reliable exploration is reduced. And they give us the code. This is nice. So we understand here in the training process, a single goal is all you need. Definitely, you have to read this. I have to read this. This sounds absolutely fantastic. Maybe a new advancement here in robotics, AI robotics. Talking about advancement, we can use now SAM2, zero-shot polyp segmentation in cancer, as cancer detection topic here. Okay, yes, I think we all know what this is about. We use now the new SAM2 technology and I hope to find here in our visual data an early cancer detection system with AI. Interesting. Next one. Oh no, this is again wrong. Sorry, this is a quantum machine learning. This is not for this channel, despite the safety and interpretability of quantum machine learning application had not been thoroughly investigated, and this work proposes here a variational quantum circuit for activation mapping to enhance the model transparency, introducing the quantum gradient class activation map. Yeah, hybrid quantum class computation framework. This is beyond the scope of this channel, but if you maybe are interested in quantum AI, there's some surprise for you. Okay, next one. We go here. A new pipeline for generating instruction datasets via RAG and self-fine-tuning. Taiwan. Okay, what are we up to here? Yes. A pipeline that leverages the power of LLMs and RAG system-related framework to construct high-quality instruction dataset for fine-tuning on specific domains using custom document collections. I see what this is all about. If you're into this, you have immediately an understanding. RAG, okay, we go on with another one. RAG, optimizing RAG techniques based on locally deployed Llama models. This is about, I've chosen this to show you here the automotive industry PDF chatbot. How they use this and why they use here the Llama models. This is here from the China Automotive Technology and Research Center. Beautiful. Wanted to show you something. Wait a minute. There was a particular way why they do this. Let's go with the general one. Offline PDF chatbots in automotive industrial productive environments, optimizing the deployment of LLMs in local, low-performance settings has become increasingly important. Enhancing here RAG techniques for processing complex automotive industry documents. And they have charts, they have visuals, they have maybe some complicated how you have to put together a specific mechanical systems. And they want to improve here RAG techniques for their specific task using locally deployed Llama models. So they do not go here with cloud-based, but they have it right in front of them. Interesting study. If you're into optimizing RAG for automotive PDF, this is it for you. Otherwise, we go on and we have now a look at transfer learning of state-based potential games for process optimization in decentralized manufacturing systems. I've chosen this for a particular reason. This here is from Germany, Hochschule Düsseldorf, University of Applied Sciences, Germany. Wait, where was it? Yeah, here. Enhancing distributed self-optimization in manufacturing system. This approach focuses on practical relevant industrial settings where sharing and transferring gained knowledge among similar behaved players improves the self-learning mechanisms in large-scale system. So you see where we're going for transfer learning, multi-objective optimization, game theory, smart manufacturing, distributed learning, machine learning. Real nice study. And next one, okay, Stanford University, pure theory, but really interesting, equivariant attention for spatiotemporal graphs. And they introduce here a transformer architecture for spatiotemporal graph data. And by imposing a rotation, translation, and permutation equivariance induced biases in both space and time, we show that the space-time transformer, outperforms purely spatial and temporal models that have without symmetry-preserving properties. So, we have the code on GitHub. Real nice. I have to look at this. Many problems we wish to model with neural networks possess underlying geometric structure with symmetries. Geometric deep learning is an Erlangen program by deep learning that systematize inductive biases as group symmetries arising through notation of invariance and equivariance. Yes, nice. Yeah, if you're into geometric deep learning, definitely this is a must read for you and for me. Okay, let's go to the next one. Building decision model making models through LLM regime, Alibaba Group. Yeah, they split here. This is an interesting paper. They propose a novel approach for decision-making problems, leveraging the generalizing capabilities of LLMs. Normally, you have this all in one swap, but here they go for LLMs demonstrate remarkable success in generalizing across varied language tasks, inspiring new strategy for training decision-making models. And they have here a new system, a new approach, learning then using. A two-stage process. In the learning phase deploys a robust foundational decision-making model by integrating diverse knowledge from various domains and decision-making context. And then they have a subsequent use phase that refines here the foundation model for specific decision-making scenarios. And this is nice, but you have to go to the training paradigm read 3.3 if you really want to understand a little bit more behind this highly informative paper. Definitely, I recommend you have a look at this if you are into this topic. The next one is an interesting one. This is from M42, Abu Dhabi. And they have developed or published here a suite of clinical large language models. You have it available here on Hugging Face, publicly available models. Really interesting, and they introduce here a suite of clinical LLMs designed to address the limitations of general models that are used maybe in healthcare settings without specific training. So they use here Llama 3 architecture and fine-tune it to specialize clinical data, multi-stage preference alignment to effectively respond to natural prompts, specifically trained to overcome the limitations in the clinical settings. Really nice. If you are into clinical LLMs, why not give it here further consideration, and it's available on Hugging Face. This is interesting, Palantir, but this is not a company that you know, but this is just a new model. So towards efficient super resolution for ultra high definition live streaming, we use here AI to live stream 8K videos, for example, and have the image decomposition done by an AI system. Yeah, if you're into this, so Palantir, in this work, we propose Palantir, the first neural enhanced ultra high definition live streaming system with fine-grained patch level scheduling. Real nice to have a new technology. If you are into this is done by Tsinghua University, of course, Simon Fraser University, Carnegie Mellon University, International Open Source Laboratory, China. Real nice idea how we can use the current telecommunication infrastructure that is a bottleneck if you want to stream 8K videos over the current infrastructure, but they're working here on a solution. Great. So on we go with the next one. Yes, if I can manage this, anchored preference optimization and contrastive revision, addressing under-specification and alignment. This is from Ghent University, IMEC, and Stanford University and Contextual AI. A little bit of a theoretical paper. LLMs are often aligned using contrastive alignment objective and preference pair datasets. This interaction between model, pair data, and objective makes alignment a complicated procedure, sometimes producing subpar results. We studied this and find that preference data gives a better learning signal when the underlying response are contrastive, and the alignment objective lead to better performance when they specify more control over the model during the training. And they introduce here now a new contrastive learning from AI revision, a data creation method which leads to more contrastive preference pairs. If you are into this is real nice. Stanford, IMEC, absolute recommendation. Also a very nice idea. You have to have this idea, like in this paper here from UC Berkeley, body transformer, leveraging robot embodiment for policy learning. I mean, how would you think about combining this? This is from August 12, 2024, UC Berkeley. They have the code available here, not a GitHub, but whatever. And you immediately understand what they are doing here with a body transformer. Look, they have here an agent graph. They built a graph structure. Is this beautiful? So body transform is an architecture that considers physical agent as graphs of sensors and actuators as nodes and edges reflecting the structure of the robot body. The body transformer leverages mask attention as a simple but flexible mechanism to provide a body-induced bias to the policy. And you have the schematic of the architecture. Real nice and tokenizer body transformer, a detokenizer. What a great idea to have this. We propose body transformer architecture that leverages the robot embodiment by providing an inductive bias that guides the learning process. We represent the robot body as a graph of sensors and actuators and rely on mask attention. The resulting architecture outperforms vanilla transformer as well as the classical multi-layer perceptron in terms of task completion, scaling properties, and computational efficiency. Hey, this is nice. When representing either imitation or reinforcement learning, and the code you find there, UC Berkeley, absolutely fantastic paper to read. And this was it for today. My goodness, we just had some papers. I thought there's a little bit more, but in general, you can say today I had about 3 times more paper that I scanned, and I decided here, just on my knowledge here, on my preferences, what I would like to learn today from all the publication August 12, 2024, and I presented to you only 1/3 of the research papers that I found. Therefore, I hope that you understand that this is just a little snapshot, a little local snapshot around my knowledge bubble. But if you are looking for some new research results, there is an unbelievable amount of information out there for you, just waiting to be discovered. And hey, tomorrow is Wednesday. So let's have a look at maybe tomorrow we get a little bit more research paper, and let's see what is the topic tomorrow. It would be great to see you.